what's called bearing. I put the definition on here. Bearing is used a lot in navigation. The military obviously would use bearing, planes, ships, those kinds of things. So when we're talking about bearing, it's the acute angle between the north-south line and the line L that we're looking at. So it's always acute, so it's always less than 90. It's measured from the north-south line. In general, we'll do N or S, which stands for north and south. Then we'll give the degree, and then it ends with east or west. E or W for east or west. The second way that you can give bearing is just a single degree measure when it's measured clockwise from due north. So we're going to just look at some lines and give their bearing using both notations. So the bearing of B from A, that is the key. For bearing, you have to have your starting point, which is where your north-south line is at. So from A to get to B, we go north. How many degrees from due north? That's my 40 degrees. And then is it east or west? East. The second notation is clockwise from due north. So if I'm just due north, how many degrees clockwise would I travel? Just 40 degrees for that one. So the two ways that we might see that bearing. For B, first notation, from A, do you have to go north or south to get to B? So it'll be north. How many degrees from the north-south line? 65 degrees. Is B east or west of A? Or, the second notation is a single degree measure from due north. That means due north is here. If I go clockwise, how many degrees would I have to travel to get there? We know the whole thing is 360, so if you did 360 minus that 65, you have to travel 295 degrees. Okay, C. So from A, do we go north or south? How many degrees from the north-south line? And east or west? Or, if I was doing a single degree measure from due north going clockwise, how far would that be? Down all the way to here would be 180 minus that 70 is 10. Alright, D. Starting at A, to get to B, we go south. How many degrees from the due north? 20 degrees. East or west of the original? West. Second notation, from due north, clockwise, how many degrees would we travel? 200. From north to south is 180, and another 20 would be 200. I'm going to put one more up here. If I did this, from A to get to B, are we going north or south? North. How many degrees is that one from due north? 0. We didn't move either direction. Okay, in this scenario, scenario, I put one on here just to illustrate this point. If it's due north, are you technically east or west? No. In that scenario, you can list either one. So if it's not east or west, you could say north 0 degrees east, or you could say north 0 degrees west. It doesn't make a bit of difference. If I were doing the second notation, how many degrees from due north is it? 0. So that's the second notation. No. Typically, I'm not going to care. You're going to have one book problem that says give the two notations. So you would have to do one of the northeast or northwest ones, one of those, and then the 0 degrees. Okay. Any other questions? So we are just going to jump right in with word problems today. We'll just practice some today, we'll do a few tomorrow, and just try to get used to it. The key is drawing a picture as you go along. So radar stations A and B are on an east-west line, 8.6 kilometers apart. If I have radar station A, east-west line would be just a horizontal line. Thank you. Radar station B, the distance between them is 8.6. So make sure you're drawing these pictures as you go through. All right. Next, it tells us that station A detects a plane at point C. Huh? Oh, okay. On a bearing of 53 degrees. Anytime I give you a bearing, you have to draw in the north-south line from the point you're looking at. So we were talking, we're at station A, so I'm going to draw a north-south line at station A. I just draw usually a dashed line. You might have multiple north-south lines in your picture, depending on how many bearings you have, okay? My bearing is 53 degrees. So if I only give you that, that means from due north, we traveled 53 degrees, and that gives us point C out here. So this angle here is 53 degrees. Station B simultaneously detects the same plane on a bearing of 323 degrees. So if we do the north-south line at B, because I'm talking about the bearing from B, if I tell you 323, that's from due north, clockwise. And we know from like here to here would be 180, 270, so 323 is going to take us up here. So we draw this picture as we go. Are there any questions on how I got this picture with my angle measurements? Okay. Now, what kind of triangle do we have to use any trig functions? A right triangle. Do I know, have I labeled any right triangles in here? Or right angles, excuse me, no. C looks like it might be a right angle, but I just eyeballed this whole picture. So you can't just look at it and say, oh, that's probably the right angle. We actually have to figure it out. But we have enough information to do that. We know that this is north-south, and we said AB was an east-west line. So when you have a north-south line and an east-west line, what kind of angle is formed? A right angle. So this here, this whole thing has to be a right angle. If this part is 53, then the part inside my triangle, 90 minus 53, would be 37 degrees. Okay, we knew that this was a north-south line and this was an east-west, so they form a right angle. I told you that this part of the angle was 53, so to find this, we just did 90 minus 53. Okay, let's look over here. We know that to get to this point, right there, we went all the way around. So to get to there would be how many degrees? From here to here would be 180, and another 90 would be 270. So if I did 323 minus 270, we get 53 degrees. So this angle is 53. Yeah, of course. Okay, so now if you add those together, that adds up to 90, which means this angle is 90. If you think about on an XY axis, so we went from here to here is 90, another 90 is 180, another 90 is 270. Does that make sense? Alright, my whole goal is to find the distance from B to C, so that is my X. We now know we have a right triangle, so now it's like doing the things from yesterday. You pick one of the acute angles in your triangle, let's use the 37. From there, X is opposite, 8.6 is the hypotenuse. What trig function involves offset and hypotenuse? So we could say the sine of 37 degrees equals X over 8.6. Multiply over the 8.6. Calculators need to be in degree mode. Let's answer using significant digits. If I'm looking at my other side that I gave you, 8.6 is just 2 significant digits. So if I were to answer this with 2 significant digits, it would be 5.2 kilometers. I know that picture is a little tricky, okay? I'm not expecting you to draw that on your own yet. But did I lose you anywhere along the way? The hard part on these is the picture itself. Once you get the picture, it's just setting up a trig function like we have been doing. Okay. Let's try another. Okay, the bearing from A to C is north 64 degrees west. We have to draw a picture. So I've got point A. If I'm going to measure bearing, what do I have to draw in? North-south, every time. Okay, to get to C, we're going north 64 degrees west. So it's this angle right here from the north-south line is 64 degrees. the bearing from A, so I'm back to bearing, but I'm looking at point A, I already have my north-south line, to get to B is south 82 degrees west. So here's my point B out here. This is 82 degrees. The bearing from B to C is north 26 degrees east. Okay, hold on one second. I'm saying if I'm at B, to get to C, it has to be northeast. You might have to adjust. B could be anywhere on this line, right? So I need to make sure that my B is far enough out that C is to the east of it. So if you need to extend your line a little bit, you can do that. Your angle measurements don't have to be exact. I'm not worried about that part. But if I'm measuring bearing from B, so I need north-south line at B, to get to C, we're going to go north 26 degrees east. So this angle here is 26 degrees. Find the distance from B to C. So we are looking for this side, right here. Oh, I skipped a line, didn't I? A plane flying at 350 miles per hour takes 1.8 hours to go from A to B. What am I going to get from that? I gave you the speed, the rate, I gave you the time. I need to know how far it is from A to B. What would I do? If you drive at 50 miles per hour and it takes you 2 hours to go somewhere, how many miles was it? You drive 50 miles in 1 hour and it takes you 2 hours, 100 miles. We multiply it. Distance is rate times time. So what I'm going to do is take my 350 times my time, 1.8, and we get 630. So that is this distance here from A to B. Okay, so I know what I need to find, but I have to make sure first that I have a right triangle. So I have to find some of my angles. You can probably find this one over here pretty easily. All three of these together make up a straight line, which is 180. So let's do 180 and subtract off the 2 we have. 180 minus the 82 and the 64. And we get 34 degrees for this angle. I don't really have much at C, but I do have something. North-south lines are parallel, right? You have two parallel lines cut by a transversal, which means this 82 degrees, this also has to equal 82, right? So what would I do to find the part in my triangle? (82 minus 26), because these two together have to equal the 82. They're alternate interior, so 82 minus 26 tells us that this is 56. 56 plus 34 is 90, which means this is a right angle. We have a right triangle. So now, if I want this side, I can take either of my acute angles. Let's say I took the 34. From there, x is opposite, 630 is hypotenuse, so that would be sine. So we'd say the sine of 34 degrees equals the opposite side, x, over the hypotenuse, 630. Multiply over the 630. So we get 352.2915. If I wanted significant digits, how many did I give you in the problem? 2. So if you wanted to answer with 2 significant digits, you just have to say 350, and we were in miles. That one was a little challenging. Do you have any questions for me? You do have to know which one your right angle is, just to make sure that you have a right angle in your triangle. Because if you don't, you can't use the trig functions. Other questions? I want to skip around just a little bit. So let's jump. We'll come back and do those 2 examples tomorrow. I'm going to do this one. This one is more like one we did the other day. We have a 75-foot flagpole. So if you draw your flagpole, the height there is 75.0, so that's 3 significant digits. Cast a shadow. Where does the shadow go? On the ground. 43.0. What kind of angle would this be? Right angle. What is the angle of elevation of the sun from the tip of the shadow? So the tip of the shadow, angle of elevation is from a horizontal up. Ooh. So we are looking for this angle right here. What trig function would I use to solve that? Alright, you guys do it on your own. Tangent? So tangent of theta equals 75 over 43. How do you move the tangent? Look at tangent inverse. So you do second tangent. 75 over 43. This gives you a decimal. How do you get the minutes? Right, take that decimal times 60. You get 10.37. I said round to the nearest 10 minutes. So 60 degrees, 10 minutes. You get that? Oh, it just Alright, let's do a bearing. I'll do this one. Take a second and draw this picture for me. Try to read it and draw your picture. So our boat is starting somewhere. Here's my boat. If I'm going to measure bearing, what do you have to draw in? North-south line. From there, we are going north, 52 degrees, 40 minutes east. So here's my angle. For a distance of 238 miles. So this side is 238. How many miles east has the boat traveled? So I just need to complete this triangle, don't I? You could draw it however you wanted. You could either, draw the bottom like this, or you could do it like that. Doesn't matter. It might be a little easier if I did this one, because then I have an angle inside my triangle. Does that make sense? So if I just think about this, if I want to know how far east, I'm looking for this side. What happens when you have a north-south and an east-west line? What do they form? Yep, so I know it's a right triangle. I don't really have to do anything extra there. So from my angle, x is opposite, 238 is hypotenuse. So we do sine, 52 degrees, 40 minutes, equals x over 238. Multiply the 238. And if you type that in, how many significant digits did I give you in the problem? 3. So if I round to 3 here, that would be 189 miles. So the next one is very similar. I want you guys to try to do that one. And that's going to be our last example for today. You have your boat. Measuring bearings, so draw the north-south line. Goes northwest this time. So this angle right here is 37 degrees, 10 minutes. This distance is 79.5. I want to know how many miles north and west it has traveled. So if you just want to complete this triangle, you can draw in those lines. North, south, and east, west form a right angle. So we have to find both of these. We need the west and the north. So to find the west, you could do sine again. Sine of 37 degrees, 10 minutes equals the west over 79.5. Multiply over 79.5. And we get 48 point, how many significant digits? 3, so what would you have to say? 0.0. Alright, to get the north, what are my options? Could I do Pythagorean theorem if I wanted? Yeah. We could also set up a trig function from here. That's the adjacent and hypotenuse. So we could say the cosine of 37 degrees, 10 minutes equals north over 79.5. Multiply that over. 79.5, cosine 37 plus 10 over 60. 3 significant digits, so we get 63.35, so that would be 63.4 miles.
What are we treating as A, or side B or whatever, so we can find sine or cosine?
C has to be the hypotenuse. A and B don't matter.
Because, I got west and north, but my answers were flipped. Because I treated, I guess, angle A as the bottom one. Starting that one there.
So the way you have it set up here, X should be here. Then when you did sine would be opposite over hypotenuse, so that should have been Y. Over 79.5. Okay. So we have learned like everything to do the homework from this section. There are 8 problems. This is going to be due when I see you on Tuesday. So tomorrow we'll finish up the rest of the examples. I don't want you to wait until tomorrow to start this. Probably some of the best problems for you to do tonight, if you were trying to do half of them, I would probably do the 4 that I marked here. So the first 3 and then problem 39 are all ones that you could do right now. Like I said, technically you can do them all, but we'll do examples similar to the other ones tomorrow.